Experiment description. Ernest Rutherford discovered the concept of nucleus in an atom. He set up an apparatus and did an experiment that could confirm J.J. Thomson's model of an atom. He placed a radioactive rich source of positively charged heavy alpha particles or helium inside a cube-shaped, thick lead box with a narrow opening. He bombarded the alpha particles with an extremely thin gold foil, approximately 8.6 into 10 raised to power minus 6 centimeters. He observed that the bombarded alpha particles scattered in different directions with different angles and were detected by fluorescent rotatable detector, which has a microscope and a screen coated with zinc sulfate. Observations. After performing this experiment, Rutherford made following observations. Almost all the alpha particles passed straight through the gold foil. Some alpha particles were deflected off at different angles as observed at the screen of the detector. Very few of the alpha particles bounced backwards after hitting the gold foil. Conclusions. On the basis of these observations, Rutherford made the following conclusions. An atom consists of a small, massive central core in which the entire positive charge of the atom is concentrated. This core is called as nucleus. The nucleus occupies a very small space as compared to the size of the atom. An atom as a whole is electrically neutral. The electrons revolve around the nucleus in various orbits just as planets revolve around the sun. The centripetal force required for their revolution is provided by the electrostatic attraction between the electrons and the nucleus. Limitation. This model could not explain instability of the atom. Rutherford scattering formula. When an alpha particle strikes a positively charged body, that is nucleus, the electrostatic force of repulsion acts strongly and alpha particles get scattered. This scattering process can be considered as cross-section for interaction with nucleus, which has point charge Ze. Thus, magnitude of force is F equal to 1y4 pi epsilon node into 2e into Ze by r square. Impact parameter. The perpendicular distance of the velocity of alpha particles from the center of the nucleus when it is far away from the atom is known as impact parameter. The shape of the trajectory of scattered alpha particle depends on the impact parameter B and the nature of the potential field. Rutherford deduced the following relationship between the impact parameter B and the scattering angle alpha.